It is not audible, Arvind, if you're talking.
Now it's fine. It's coming. Now. So,
Arvind?
hello. Now voice is coming. Hello.
Yeah, now it is coming, but very low actually now. Earlier, I mean, there was no voice at all.
Now are you here? Hello.
It's very clear right now.
No.
Now is it fine? Hello.
Yeah, it's fine. Can you able to
We can
hear us?
hear you, Arvind.
No.
Yeah. Now it's good in this time. Hello. Hello.
Yeah, Arvind, I can hear you.
Okay. Okay. Fine.
Yeah,
Fine.
it's clear now. Yeah.
Okay. Okay. Fine. That could be a problem of. Okay. Okay. So first we check here Hadoop FS. Okay. So we can see all the command here. So the command is a text command. Okay. So if I want to see the complete syntax of the command, so we can use help and text text command. So it is saying like this text command, take a source file and output the file in the text format. So it's like we create some zip file. Okay. And we will upload the file, that zip file we will upload onto the Hadoop file system. Okay. So I will create a one text file. Okay. Okay, I created this file. Now I will create any name I can give. Okay, and I'm telling here my file is in my local path, right? So I'm creating zip.txt. So I have created a zip file, right? Now this file is a zip file, and I will copy into the Hadoop file system because I want to see the content of this file in Hadoop file system. So Hadoop fs minus put, and I'm putting this text.zip file. Then I will give some location workshop 2. So this is my already Hadoop directory is there. Okay, now I will do Hadoop fs minus text command. Then I will give whatever my zip file name I will give. So my zip file name is workshop2 slash workshop 2 slash my zip file name is the text.zip. So it should be zip of only one file. It's not like that, like you can put like 10 file, or then you can say one file I want to see. So can you see it is coming encrypted, but this is coming the text you can see, right? You can find your text. Hello, hello is there. How is there? RU is there, right? So you can read your content, right? Because zip has a lot of header and footer is there. Okay, so that part is not for our use, right? We can leave that part. So the main content part that you can read here. So this is the content part, right? This one. Okay. So whatever zip file you create for a normal text file, that file you can see content, just you do text command. If you try the Hadoop cat command, see what happens. Cat command will not be able to see the content of. Oh. If you go, okay, it is not coming back. Okay, so if I do cat command, because cat cannot read a zip file. Like cat also working, but cat is giving just whatever the zip content is there. Okay. Okay, so we generally use the text command, right? So we can read the content. Okay. Anyone has any questions? So Hadoop FS, so you can see the complete all file list command here. So I have already covered all the commands. Okay, last time I believe, right? All the commands are covered. Okay, so now I will be showing today MapReduce. So first I will go through the MapReduce fundamentals. Okay, then I will show you the MapReduce program. Okay. So first we understand what is like MapReduce, right? Map and reduce, they are the two functions. Okay, and what is the MapReduce architecture? Okay, so MapReduce is a processing component. Okay, MapReduce is a processing component, right? We know, right? There are the two functions in the MapReduce. One is a processing, one is a map, and another one is a reduce. Okay. So what was the use of the MapReduce? Like we say, we have the different programming languages, right? We are using, right, Python, Java, right? All these programming languages can process any type of data, right? Like if I say text structured data, right, we can process, right? So why we need a MapReduce? So MapReduce is a parallel distributing computing processing framework, right? The data can be process parallelly in a cluster. So that part Java, Python programming languages cannot do in the parallel processing in the distributed computing environment, okay, in the cluster environment. So only one system you can use this Java, Python language, you can get the benefit. But when you are doing in the cluster, so earlier, like suppose if I say I want to find a word count the earlier time, how it is done. So every system, suppose I have a 5 machines and my data is distributed. My data is not interconnected, but my data is there on these 5 machines. So I will run my program. I will run my program, Java program I will run or Python program. I will find the word count. Okay. In each program, each machine, I will run the program and find the word count on each machine. Okay. Each machine. And then I will aggregate my result and then aggregate my result and get the final result. Okay. So this is kind of like manual activity, right? You have number of machines are increased, right? So you don't have distributed computing is not there like Hadoop, because in the Hadoop cluster, everything is managed by Hadoop, right? Because one master name node is there, other are the data nodes. So this parallel processing, like name node is distributing, name node is taking care of all the data node, resource manager is taking care of all the node manager and allocating the task, getting the result of the task. So this all done in the Hadoop cluster. So what happens in the MapReduce, like if I have a data on 5 machines, so data is parallelly distributed. Data is parallelly distributed on these 5 machines, distributed on these 5 machines. And once the data is distributed on these 5 machines, then this is called the map process. In the map is called splitting the data, into various machines. That is the map process into various machines. Okay. And once the data is processed in each and every machine, then finally finally result is aggregated to one single machine, aggregated to single machine, aggregated to single machine, that is called reduce. So this is the same thing. If I'm not wrong here, this is the same thing, whatever is earlier time. So what is the difference now and that one? The difference is this aggregation, whatever you are doing manually, that is not done manually by you. Okay. So this all is completely done by the MapReduce program. So MapReduce program is handling this entire this splitting the data and aggregating the data. This everything is handled by the MapReduce. Okay, so now we come to write this MapReduce is written in Java. The program we are writing in the Java. Okay, why people are not using the MapReduce nowadays? Because the reason is the MapReduce program is 200 lines of code, and for simple word count program code, if I'm writing simple word count program, it takes 200 lines of code. 200 lines of code means not one single class. There is a one driver class, one mapper class, and one reducer class. So these are the classes out there. So this is a overhead, right? Like productivity is very less, right? So in one simple word count program, if I do in Hive or Spark, I will write just 2-3 lines of code. Okay. So that's because people have stopped it to use MapReduce, but still MapReduce is used for the unstructured data handling or semi-structured data like file conversion, right? From one file format to another file format. The reason is because MapReduce is using Java, and Java, whatever you can write a code in Java, you can make it distributed parallel processing you can apply. Okay. So whatever code you think, right, okay, you have to process in the parallel distributed manner, you can write still Java. So MapReduce code is still can be written, but for the complex use cases, not very simple use cases. For complex use cases where you cannot achieve something like if I say some processing Java image processing API or so those kind of code you can write it in the MapReduce, which you cannot do in the Spark. Or if Spark, if you want to go, then you have to use machine learning libraries. Okay. Okay. So now we come to how to start the MapReduce program, right? If I say, just say, take an example, how MapReduce works internally. So far, we just thought about, okay, map function is there and reduce function is there. So just assume is like I have a one test.txt file is there. In this file, I have a some set of line is there, right? I have a hello, how are you? Hello, how are you? Okay. Suppose I have a 2 lines of text is there in this file, and I want to do word count of this file, word count of test.txt. So my result should come, final result should be hello, comma 2, how, comma 2, r, comma 2, and u, comma 2. This is my result, right? So this result, but ideally the result will come alphabetically sorting order, right? Okay. So this will come first, and then this is fine. So this result I want from my file. So when MapReduce program, what it happened, so MapReduce is shipping this program. When Hadoop framework, what is doing is shipping the program on all the data node where your file is distributed. So who will tell about this? Name node will tell about this, because name node has the information about all the data nodes where this file is distributed on multiple data nodes, right? So MapReduce program, first of all, is shipped to the, because the principle of MapReduce is the data is not shipped to the node, the program is shipped to the node. Which one is the less cost? If you ship the data to the machines, or you will ship the program to the machines. Program is just hardly some KBs of the program, right? If I say this MapReduce program code, the 200 lines of code, it will be hardly some KBs of the data. Okay, just I say 100 KB. Okay, just I'm assuming. And this program, this 100 KB program, if I'm going to ship, like suppose 10 machines, which is faster? Or if I say I have a 100 GB data, I will ship to 10 machines. Okay. So now the approach is in the MapReduce is the approach is like ship the program to the machines where the data is there. So shipping the program to the data, not the data to the program. Okay, because data to the program means, right, if I say this one machine, because my program is suppose here, and if I'm trying to do the 100 GB data to ship to one machine, that is not a good idea. Okay, so 100 KB program I will ship to the 10 machines. Okay, so this is the first thing. Okay, and after that, like how the MapReduce program starts here. So initially this your file, this file has every line is starting some offset position, right? Offset is nothing but your starting of the line of the position. If I say this line is starting from the 0 position, okay, so I'm saying the 0 is the offset for this. If I say this line is starting from how many character are there in this line, so some position is given, okay, 25 character, okay, 25 come. So this is just for make sure our whatever data you are writing in the file, same data you can receive. For this particular case, it's not a issue, right? Even your word count, finally you need a word count. It doesn't matter whether the text of content up and down, it doesn't matter. But when you are reading or writing file, then the offset is very important, because in which sequence you are writing the file, the same sequence you want to get the file back, right? Otherwise you will not get the correct file. So if I say every file is having, like here is the offset is there. So when this file is given to the map function, the map function is taking a key value pair. So what is the key here? Key is here offset, and that is called long writable number. So here I'm just writing a 0 or like this, but it is actually some long writable number. And this long writable number is the serializable type. I already told about, like when the data is transferred over the network, it should be serialized, because when the same data which you are copying on the one machine, so it should be transferred over the network, it should be serialized. So serializable data type is long writable. So whenever the data will transfer to the another machine, it will convert back to the long, okay, for the manipulation of the data. But whenever the data is going over the network, it will go long writable, double writable, or text type. So second one is type is in the key value pair is a text, because this line of text is a text type. Okay, so again, this is also serializable type. Okay, so map function is reading these two parameter. One is offset position, second one is the your text of line, right? So once this map is reading this two parameters, so what it's doing, it is splitting this line with the space, okay, with the number of words, and each word is giving one count. So map is taking your key value pair and returning also key value pair. So what map will return here? Like hello comma 1, how comma 1, right? R comma 1 and U comma 1. Okay. Same thing will happen for the second mapper. So one mapper means one machine. So this line will go to the one mapper machine, and this line will go to the another mapper machine, because we are doing distributed computing, right? Like mapper, this all things done internally. We are not handling this part, like how the data will be distributed. So block size, right? The block size is a key here. Block size is a parameter. Based on that, it will distribute data into the multiple machine. So here we are assuming this line of text is not so big, right? But we are assuming this data is on one machine, this data on one machine is going. So how map function is returning key value pair of line of text data, right? Whatever number of words. So here is again hello comma 1, how comma 1, r comma 1. Okay. So as per my text, I'm giving an example. Okay, it could be anything. Okay. Okay, this is just an example. And these two mapper machine, this is the first mapper machine, this is the second mapper machine. So these two mapper machines are parallelly running. But sometimes the situation come, might be this third mapper machine, suppose I'm saying, suppose this is starting from the some character. Okay, I say 45 comma, only one word is there, hello. So in this scenario, what will happen? So this mapper will be complete first, right? So this mapper will complete first. Okay, so it doesn't matter, it will complete first, but further process will not continue till all mapper are not completed. Otherwise, your data will be conflicted, right? So what happens, like other mappers have to wait. Like suppose this mapper is completed quickly because it has the less data, but the other mapper having more data, so they are taking more time. So all mappers should be completed finally, then only the next phase start. So these are the stages. The first stage is a map stage, and map stage is returning the output as a key comma value, taking input as a key comma value, and returning output as a key comma value. The next phase is the shuffle and sort. So shuffle and sort is basically two things are there in the shuffle and sort. The one is, first it will be doing shuffling from the different mapper to bring the same key at the one place. So if I say hello is 3 times, so hello comma 1 it will bring. Next is the how is a 2 time 1, 1. Okay. And R. So it will be sorting also now. Okay. First it will be doing shuffling and then it will be doing sorting. So R, 1, 1 will come first as per the sorting. Second one will hello, HELLO, and then how 1, 1. And next is U. U is 1, 1. So this is again key value pair, because this is a key and this is a value. So shuffle and sort is processing the data, and this is an intermediate stage between the map and reduce. The shuffle and sort is taking input key and value and returning again key and list of values, because one key have more than one value. It could be chance, right? So key comma list of values. So again is here key value. So complete map reduce is list key and value, key and value, key and value. Okay. So if after shuffle and sort, the last phase is the reduce phase. Reduce. So this reduce is basically, so this reduce is function which is combining your whatever the result came from the shuffle and sort, it is just aggregating the final result. Okay. So if I say R comma 2, okay, hello comma 3, and I say how comma. So if I say here how comma 2, okay, so how comma 2, how comma 2, and next is U comma 2. Okay. So this is my final result, and it will be written my some output.txt file. Output. So it will be written. Okay, U comma 2, and it will be written. Finally, this output will be written into the some output.txt. So this is my final word count program. So this looks like it's a long process, but it's depend on the data size, right? How much data is there, it will take the time to process the data. So this is the MapReduce architecture. If I show you the diagram, you will clearly understand, right? Like how in the actual diagram MapReduce word count. So this architecture, why we need to understand? The reason is like because all the Hadoop ecosystem component will be using this architecture internally. So we are manually doing this one. We are manually doing this thing, but when it comes to the real architecture, right, for the other Hadoop ecosystem component, so they will be using this architecture. So if any MapReduce program you are writing manually, right, so you are defining all the stages, right? This is a map, this is a, so but when it is coming for other Hadoop ecosystem component, then it will be doing. So you can see here the same diagram which I have written as a text, right? So it is in the boxes, right? So here you can see splitting the data, that is a map function. Then it is returning each word is a one count. And then it is just doing the shuffling phase and finally reducing phase. And finally it is the output, right? So this is the same thing, right? So this is the basically the MapReduce word count program, okay? Now, next thing, like how to start this MapReduce program. So we have one driver.java class, one mapper.java class, and one reducer.java class. Okay. So driver is called here entry point, right? Driver is a class which is the entry point of your program. Like your program will start from here and terminate also from here. Entry and terminate. So finally your program will start from here, and finally your program your program will finally at the end it will be terminating from here. So entry program and driver is starting the mapper. So the flow is driver to mapper, mapper to reducer, and reducer to back to the driver. So this is the flow. So driver to mapper, driver to mapper, mapper to reducer. So it will jump it, mapper to reducer, and reducer to back to driver, and then terminate the program. Okay. So this way, finally, your MapReduce program will execute. So this is the execution things we have seen. And driver class, we have to define one job object. And this job object, we have to set different configuration things we have set. So set mapper class we set. So we have to tell, right, what is my mapper class. So I will say my test mapper dot class. So I will give the mapper class name. Same thing, like if I want to set the reducer class, so I will say job dot set reducer. Okay. So I will say test reducer class. So some class name I have. I will show you this code, right? So how this code is written. Okay. So job, and then finally job, like we have to start the job. Okay. So start, wait for termination. Some function is there. Start or wait termination. Okay. So this function will be start your processing and wait for unless like your control come back to the driver. Finally, everything is done. But maybe the chance, suppose your program is failed in the mapper. So there is a one exit code is there. If your exit code is coming 0, so it means your all the phases are completed successfully. Okay, exit code 0 means all stages are completed successfully. All stages are completed successfully. But if you get the status code exit 1, so that means it is failed. It is failed anywhere. It could be failed in the mapper stage, or it can be failed in the shuffle and sort, or it can be reducer. So you have to check the log. So you have to read the logs, right? The console log, right? And then you can find the error, and then you can correct your program. Okay. Is it clear this one? Okay. So how to write a program? Like I'm going to show you.
I mean, I have a few questions. Can you?
Yeah. Yes, ask me.
You have to show me that.
Okay, 1 second, I'm showing the ID. Okay, so where in the text file? Okay,
So here you said in line number 21, program is 100 KB and it is 10 machine. Means you means in all the nodes this program is going to execute.
not all the one. Actually, I given this 10 machines means where my data. Suppose you have a data to process, right? By this MapReduce program, that is your program. That data is maybe like 50 GB. Okay, and this 50 GB is distributed to the multiple nodes, right? You don't know about that, right? Because
Right.
that is internal, right? So that's the reason I'm saying this. All things happening internally, and when we are saying this. This program, right? So this, when you say 100 KB, so basically that is strategy of the MapReduce program. So what it will do, the complete MapReduce program, what you are submitting a job, right? So its class file, source code is not needed, right? Because source code is not executable, right? Java classes, class file. That class file will be copied to those 10 machines where the data is available. Because where data is not there, what is the point of copying that program, right? That is no use. Yeah.
And apart from that, in line number 24, you said offset long writable and text. So here long writable is
Key. That is
key.
offset
Okay.
position. Actually, this is also for not our use. If I say in my MapReduce program, you will not use that offset. I will show you the code. You will see this is for internally when it will find the position of the, see, this is a memory location. Okay, I'm saying offset. I have just given a number 0, 25, 45, but this will be some unique ID position. And that is a memory reference, C++ pointers concept is there, right? To find the memory location. So
Okay.
this offset is not for our coding purpose. Okay. We are writing simply logic, like how to split the data into hello, comma one, how can we give each word is a one count, and how to combine the value of all same key together and make one single value. That's our logic. Okay, you will see when our logic is very, very short, just only 3 lines of code in the mapper class and 3 lines of code in the reducer class. But lot of extra code is like an import statement is there. Java program, for simple one single line of system out.println you want to write, you have to write 10 lines of code. Okay, 5 lines of code, right? Because you have to write braces, you have to write main function, correct? Right? It is not like a Python as a scripting language. Python, like if you write just print hello, it will print. No need of main function. It's not mandatory. But Java program, the problem is it's a main function is mandatory. Without main function, you cannot start the Java program. Okay.
And one last question is, means when we are saying sort and shuffle, sorting, yeah, I understand, but shuffle I always forget. Means what happens in shuffle?
Shuffle is, suppose this data is in 3 machines. I'm already saying this. It could be a more, right? I'm just taking an example. This is for making you guys understand. Suppose this hello is one here, this hello is here, this hello is there. How they can come together at one place? So shuffling is needed, right? If you have seen in the diagram, you can easily see here this kind of shuffling, right? This is shuffling
Yeah,
only, right? So
through
this shuffling
network it
means,
have to come together. That's
yeah,
called
like
shuffling.
find out the
Got
same
it,
word
got it.
together and bring it to at one place. Otherwise, your word count will not happen if I'm not able to do. Okay. So that is the reason next reducer phase is this reduce class, which is doing actual calculation. Okay. So shuffle and sort is just to bring the values, but no need to do calculation, no need to do the sum. But when the reduce will come, it means it will do the actual count sum.
Aggregation. Yeah.
Okay, aggregation. Okay. You will see the MapReduce program, you will understand. Like, see, first why the concept need to understand before going to the actual program. Because if we don't understand the concept, then we cannot understand the program. Okay. So Java program is not like, it's not a matter of Java class to understand. It's a matter of, right, how this logic is written, what is the logic is divided. Because logic is not written only in one single class, like just only main class is a starting point, but that main class is a driver that is not doing anything. That is just invocation providing for mapper and reducer. The actual logic is written in the map and reduce. So driver is just a starting point, like your program should be invoked. So only one class will be main. The other classes will be triggered from the main, because it is like just every class doesn't need main, right? Why unnecessary I need main? Main means where I say, okay, I should say this is my main class, my starting point is here, but I will call the function from this class. Okay, see here, this is a driver class. So I just given a name of the driver class word count job. Okay, so name could be anything and it is a main class. And I'm creating a job object here and I'm setting a Java jar by class. So why I'm saying it, suppose your project has multiple main classes. So how you can recognize which main class you have to call, right? So this particular main class, suppose if I give in my program when I'm running my this MapReduce program, so I will give this jar class name. So when I give this class name, so in this jar, only this class it will pick, because other class is also main class. Why it will not take the other main class? Because I'm pointing out the name of the main class is word count job, right? So that is the purpose of setting this property. If you have more than one main classes are there in your jar. If you have only one main class in your jar, even if you don't keep it this, it is fine. Otherwise, it will confuse, right? Which main class I should call, right? Okay. Okay, so mapper class. So mapper class is this mapper class is there, and one class is a reducer class. So I'm setting the mapper class and reducer class. I'm setting it. Okay. And another property you can see here, output key class. Even your mapper or reducer class are here. If I comment this code, my MapReduce program will not work. Why? This is a combiner class. Okay, this is not needed here. Actually, combiner is improving the performance of the MapReduce application. So let's comment this one. But mapper class or reducer class, if you comment any one of the class here, so your program will not work. Even though class is there, it's no sense. If your class will be used 100% when this property is enabled, right? Uncommented. Okay. So your class is here or not, it's not, doesn't matter. So your program should have this class enabled. Okay. Same like I have done reducer class, and the next property is a output key value class. So I'm telling here, whatever my final output is coming, that is my text type, and value is the integer type. If you see this output, this is the output, right? Reduce output, like reduce output, where it is gone. Okay, it is actually here. So this output, you can say text is my key and value is my int writable, right? So this same thing I'm returning here as a output key class. I'm saying key means whatever your key type, that is a text type, and value type is int writable type. Okay. And partitioner also I'm not going to use in this program. Partitioner is also one more extra component, but it is optional. Right now it is not needed for our word count. Next thing is, in the driver class, I'm setting what is my input path, right? Where I'm going to read this file. So I'm going to say, okay, I'm going to read this file. I'm going to read this file on this particular path. And when I'm saying like where I'm going to read this, where I'm going to write my output file. So I'm telling this is my output path. This is my output path where my file will be generated. Okay. So I'm going to tell my input file and my output file. Okay, so both I'm going to tell my input file and output file, and I'm setting my format, my file format type. So I'm saying my input format type or output format. I'm setting here my like this is a text format, and this is the last one is job wait for completion. So this will, if it is successfully done, it will return the exit code 0. Otherwise, it will return the exit code 1. Now we see the mapper class. So mapper class is having map function. You don't see this one. This is the setup is actually given here, but it is not required. This is the main important function is a map function. Can you see this code? What is doing? It is taking 3 parameter. One is the object key, that is your like long writable type of key, basically the offset, and text is the input, the line of text, and context. So how the data is sharing, right? Because you know, mapper, reducer, all are different machines, right? So how this data is shared, that is the one context share variable. So this context is a share variable, which is a shared location. You can say shared location. How Hadoop is doing, we don't know. But this context is a shared location or shared variable. The anything you put in this, the other machine can get from this. This is like this. So context is the shared variable. You always write in the context. The other machine will read from the context. Again, it will write into the context. So every mapper machines will be reading and writing like this. Okay. So suppose I have taken my text of data. I have used the space, right? I'm doing a split because very simple logic in the Java. So every line of text I'm taking. And one more thing you see here I'm getting a text type input. So why I can't do directly split? I cannot do because I can perform some Java operation on the string type, not the text type, right? Text type is a serializable type. So if I try input dot split, you will not get any method. So input dot split is not there, right? Because it's not a string type. Input split, input is your like serializable type. So serializable type is used for transferring the data, not for manipulation. Okay. So once your data comes here, you have to make it a string type, and then you are applying the split function and get the data as an array. Because if your first line is having hello, how are you? So 4 word you will get. Second mapper will get hello, how are you? 4 word you will get. Next mapper is only one hello. So it is running a loop because this MapReduce program is everywhere, right? Wherever your data is splitted, right? So all the data, this MapReduce program is everywhere. So it is writing the key So hello is writing and 1 comma writing. Every word, even hello is coming 2 times, but it will give hello, hello 2 times. Okay. If hello is 100 times, it will write hello, hello, hello 100 times. So that thing we will overcome by the combiner that I'm going to tell next. Suppose in the same mapper, you have another one more hello, or I'm saying 100 times hello is there. But if you are not using combiner, what will happen? If you are not using combiner, it will be every time 1 hello. And 1 hello means it will be taking a more bandwidth, right? If your data is transferred over the network, so unnecessary you are sending hello comma 1 100 times or 1000 times or 10,000 times or 100,000 times. Okay. So whenever the data is repeated, your performance will be degraded. In that scenario, combiner comes in picture. What it will do, whatever, see, it is exactly the reducer thing, right? Whatever you are doing in the reducer from the different mappers, so same reducer code you will apply as a combiner in the same mapper. Okay, so whatever code I'm showing here, this driver you seen, this one, combiner. If you make it your combiner class as a reducer class, because if you see reducer, both are reducer. So if you set it combiner class reducer, so this aggregation will automatically happen for the same mapper. But still the data is coming from the different mapper, that will not be aggregated at the mapper side. That will be aggregated same reducer wise. But suppose this hello is coming 2 times here. So when it will be aggregated here, it will become automatically hello comma 2 from this machine, hello comma 1 from this machine, and hello comma 1 this machine, to total hello comma 4. Okay. But if the same machine, if you have hello 2 times, 3 times, 10 times, 15 times, so it will be aggregated as a single value. So that is the advantage of the combiner. Okay, we will see that later. Okay, but I'm telling you, like here, the purpose of this code is to, in the mapper, is to giving each word is a 1 count. Okay. Now the next is shuffle and sort is not any code we don't need to write, because this is the internal process. There is no code for that. So whatever mapper is doing its job, after that reducer will come in the picture. So what reducer is doing, it is just 5 lines of code. So reducer is getting the key and list of values of your word, right? Okay, like hello is 3 times, so hello comma 111. So list of values I'm iterating here, and then I'm getting the +1 +1 +1, and then I'm making it final number. This final number I made it, right, after aggregation. So you were thinking, right, how this aggregation is done. It's just simple calculation, right? Just each value we are doing plus plus plus. So if I say I have a 5 item, I want to do the sum. So you will add 1 by 1, 1 by 1, 1 by 1, right? And then you will get the total item cost, total cost, you will get it. The same thing is here. But one more thing is here, this all values is coming, this is an int writable type. So you cannot do the operation on that. So you are using the get function here. So get will make it a primitive type. Okay, because Java is supporting primitive type, not serializable type. Okay, so you cannot do directly some operation on the value. So you have to call the .get function, and then you will add in your initial value 0. And finally, when you get the total number, you are setting again context. So I told you the context will be everywhere is there. In the complete MapReduce program, the context is a common shared variable, which is sharing the data from mapper to shuffle and sort to reducer, and finally you are getting the output. Okay. So these 3 classes we need. Okay. Even these 3 classes you can write in a one single Java file also. So right, public class you have to create with the name of the driver class. Okay. So there is a one example I have there. I have created all the 3 classes in a single class. So if you see here, like this is a reducer side join. And so one is a custom mapper class. So this is a static class. So this is the logic of the splitting the word like that one. This is a second mapper class. This is a reducer class. All are the static class. So this way also you can write the program, and this is a driver code. Okay. So you can write in a single file all the classes. but you have to set it here. You have to tell here what is my map class, what is my reduce class, okay, that you have to tell. So in this driver class, how to run? Now question comes. So there are the two ways to run. One is you are running in this program to the IntelliJ here, or you are running this program to the Hadoop cluster. Okay. So if you are running this program in the local here, I want to test some output. I want to test some input, and I want to find the word count. So here is the edit configuration is there. So you go to your edit configuration. So here this MapReduce WC, right? Suppose you say I have a one input file. So let me show you this input file, this my home location. Test one. Okay, so test one has one input file XYG. So this file, if I open, you can see country names are there, and these countries are all repeating. If you see Indonesia, again Indonesia is coming, again Indonesia is coming. So same thing, these 4 lines is keep repeating. Okay, right? So these 4 lines is keep repeating. Okay. Now I want to do the word count for this file. Okay. So what I gave here, I have given my, so 2 parameter you have to pass. And what is my driver class name? This is my word count job. I'm giving my driver class. Okay. So how to create this one? You know, just create a new configuration, click on this application, and then it will come unnamed. Just give any name, MapReduce word count. Okay, and here you find your word like driver class. So word count job is my driver class, and I have to give the parameter. So I have to give the location of this. I have to give the location of this input file. So input file location is this. So I'm running this program for testing purpose, but actually it should be run always in the cluster. Okay, XYG. And now I will be giving some output file directory. So, you know, whenever you are creating any running in a program in Hadoop, right, it needs to create always a new directory. So I'm saying here word count output. So this directory is not there. If you see here, you will not find the directory here. So I'm creating my output file here. I want to create my output file here. Okay. So I have given the directory name WCOP, and inside this directory, one output file will create part -r-000. So now I just set apply. Okay. And now I will run my program. Okay. So can you see the exit code? What is the exit code is coming? 0, right? It means our program is successfully run. Now, if I'm going to check WCOP is created, if I check here the part R file, I will see this is my word count. But one space is there somewhere, so that space is counted as a one word count. Can you see this is the all words are coming? But how can we make sure, right? This is a 18,312 times. This is a 18,312 times. We cannot count it, right? We cannot check manually, right? So how to test it? So there is a one way to test it. Just suppose you copy this one word, okay? And after this one space you give and paste it, correct? Got it? And now I save it, okay? Same program, I run it now. Let's see. So how many word increment will be there? Only Germany will be increment by 1, right? Whatever is there, right now what is there? Germany is coming, this one, 340, right? 18,340. So how much it should be after running our new word count? 350, right? So now we just run the program. And why I'm not creating a new directory again? Because my program is handling that part. It is deleting internally this directory, output directory, and creating. Even if you don't delete, but if this line, if I remove it, I have to give a new directory name always, like this edit configuration. I have to give the new directory name, whatever the configuration we created, like this WCOP. So I have to give WCOP1. But why I'm not giving now? Because I have handled in the program itself, right? So we don't need to create. So I'm running my program again. Okay. MapReduce program, see how fast it is. It is completed. Okay. So if I check it now, WC, okay, I'm not going inside this because the folder is same, right? So I just check here, it will automatically got refreshed. What is saying? Change on the disk, right? I have to reload. Can you see it is changed? Any other thing change? No, right? Only this one change because I added a one more word, right? That's the reason. Okay. So word count, this is a simple MapReduce word count. Now, if I say, Abhi, right now my combiner is working or not? Let's see, my combiner is not working. My combiner is commented and so many words are repeating, right? So definitely combiner should be used here because if I say, if my words are not repeated, whether you use combiner or doesn't use combiner, it will not be giving any performance output. But if I just put it this combiner enabled, and now I will run the program. See here also we will not see very remarkable performance because our data should be very, very high, right? See, so because see already your without combiner also it is fast, right? So what the performance you are gaining here, right? So I'm saying it is done, okay? But output wise, there is no difference, no change. Again, if I refresh it, there is no change because I have not added any word. I have not done any. Combiner is just improving the performance because if the same mapper has the word twice, thrice, or 100 times, so it will do reducer. It will apply the reducer on your combiner. And one combiner, one reducer is there, reducer is already there. But this is special combiner is a special class which is applying reducer at the mapper side. Okay. And one more thing I'll show you. Suppose I want to, I mean, right now, how many words are coming? All the word in coming in the same file. Suppose if I say I have these words are 100,000 word in the same file. Okay. Word count. Can you identify that one particular word in, you have to search it. Here you can easily find, okay, I want India, I can check it and this is India. But if I say here the word count for 100,000 words are here, can you identify quickly? You have to search manually, right? You have to search, right? I'm not saying like control F and then you can find. I'm saying manually how much time? You will take some time to search, right? It's not that much easy. But if I do one thing, if I distribute my output into the multiple files with their starting letter of the word, if I say all the I should come into one file, all G is come into one file, all C China will come into one file, all P, all U. So it will be little easier for me, right? If I say if A letter starting word in a one file, I will know, right? This file is my A letter word, right? So I will not go to the other file. There is no point to go to the file and check. I don't need to go. I don't need to go, right? So this thing is done by the partitioner, but partitioner need to write a one class. So first of all, we have to enable the partitioner. And the second thing is we have to tell how many output file you want. So in this scenario, I say I want to create a 3 output file and write the logic in this class. What is this class? If I go to the custom partitioner, so my logic is if the letter is starting with A letter, it will go to the return 0. So this get partition function in the partitioner class having get partition function, which is taking your key and which is taking your value, right? Whatever count value and number of reduced task, like how many number of output file. If your number of output file is coming 0, suppose you have put it 0, means you don't want any number of output file. 0 means only one file. So this will act as a hash partitioner. So hash partitioner is a default partitioner, no need of custom partitioner. But custom partitioner is needed when you want more than one output file. So by default partitioner is there, hash. If I don't use this custom partitioner, if I commented these 2 lines, it will use hash because I'm not specifying any partitioner. But when I say like I want to use the custom partitioner, so in that case, it will use this custom partition logic. In that case, it will check the key is a starting A letter. It will go to the one file. G letter will go to the one file. And third one case is all words will go to the third file. So here I'm not distributing all 26 letter file because I'm assuming it like A letter one file, G letter is one file, and rest of the words in the other file. So whatever I want important, I can make it. I can make it a separate file for that. Other words all will be in a one file. So this logic I have written here. And when I'm running now the program, so your output will automatically come into 3 files. Everything will be same. This all things will same, but now the output is distributed into the multiple files. Okay, now I'm running the same program because I have enabled partitioner class. Just I run on this. Even if you understand the concept and speak this, like MapReduce concept, if someone is telling, right? So someone will understand you really know the Hadoop fundamentals because these are very internal concept. And if you are not writing the program, it's different thing. Nobody is asking to write program, but understanding the concept, that's very important. Okay, so now in the same WCOP folder I go, can you see 3 files are created? Earlier it was a one file. Now 3 part file is there. Now if I open these 3 files, I will say the first file is a 0. Okay, if I reload, there is no word because there is no A letter word. There is no A letter word, right? So that is the reason this file is empty, but still the file is created, right? Second one file is a G letter, right? So only one G letter country, right? Only one country is G, Germany. Rest of the words will be going to the other country, other file. Is it clear? Right? It's distributing your output into the multiple output file by the partitioner. Okay. So this is our all MapReduce because MapReduce having one more thing is join also happen, right? You know, join in the table. We know the join happens in the table, but join also happen in the MapReduce, right? Like you can join 2 files. Like if I say one file is a employee file, if I give the example, like if I have a one file is a employee.txt and one file is a department.txt. So if I say employee is having employee ID 1 and name is test and department is 101 and department txt has 101 and department name is okay admin. So if I want to combine this data and I say 1 test and 101 and admin, like this data I want to get as a output. So this kind of join is called map side join where the data is combining. So 2 types of join, map side join and reduce side join. Okay, I will cover tomorrow this join and tomorrow I will finish this MapReduce. Okay, I'm not putting much stress on this MapReduce because I want just you understand concept and if you can do practice and I will show you how to run the same program in the cluster, how to create a jar of this program and how to run on our Hadoop cluster right here, right on the like Hadoop jar command. So there is the one Hadoop jar command. You can run your program. So then you provide the main class name, argument, and this all. Then your program will run on the actual cluster. Right now, this program is running through just jar. Even if I stop my Hadoop file system, even if I stop all .sh, my program will run. Okay, so my program is not impacted by my Hadoop file system. Okay, but if I want to test actual Hadoop cluster, right, my performance of the Hadoop cluster, so I have to create a jar of my program and then you have to use Hadoop jar command. Same thing we will do in the Spark also, because when you create a Spark program, you will create a Java program or a Spark, Scala or Python file. So you have to submit on the job on the cluster. Okay, but testing purpose, why we are doing here then? What is the use in the editor if we are not doing in the real time? This is for just testing because every time you can't take it to the cluster for your testing, right? So testing you will be doing locally in your editor, checking the logic, right? If my logic is working or not, right? So this is not the way, right? Every time you will take it to cluster, like you have to upload the file, you have to run a command there, right? So this is a lot of headache, right? So if you have the program locally, you can set some small data, right? You have some small text file, you can test logic. Once your logic works fine, then you take your program, create a jar, and then take it to the cluster and run your program. That will be a actual processing logic related on it. Okay. Okay. So anyone has any questions? So I will share this recording. So you just go through it. Okay. So MapReduce is little complex, I understand, but we have to learn like just theoretical fundamentals because of interview point of view. Sometimes they ask what do you understand by MapReduce. So if you have fundamental knowledge of the MapReduce, so you can speak right about the MapReduce. Okay.
Two questions are there. Means partitioner and combiner, those are two for performance improvement, right?
No, partitioner is not for performance. I told combiner is performance. Partitioner is just making ease of use for you to get your output file. Okay, partitioner
Okay.
is not giving a performance. Combiner is giving performance. Okay, partitioner is just making your readability purpose, right? Like, okay, you can easily search your data, right? So it will be making it your output easy, right? Number of output file, but it is not performance. Okay. Any other question? Anyone? Okay. Yeah. Thanks, everyone. Thank you.
Thank you, Arvind.